Here at the University of Washington, climate change research is performed across disciplines by physical scientists, social scientists, and by graduate students like me. I'm Greta Shum, a PhD candidate in atmospheric sciences. The Program on Climate Change, or PCC, brings together all these people through education, research, outreach, and most importantly, by fostering an inclusive community. Thanks to the PCC, I've taken interdisciplinary classes on climate, helped to organize an international conference by and for graduate students, and connected with faculty on research across campus. Students like me can take on leadership roles within the program, collaborate on community science projects, and form and strengthen connections to the research community at pub talks, symposia, and my personal favorite, the annual PCC Summer Institute. This community welcomes everyone, whether you're thinking about climate impacts, climate education, or fundamental earth science. This is an all-hands-on-deck moment for our planet. Every one of us has our part to play, but thanks to the PCC, we can do it as a team.
Hi, I'm Ann Bostrom at the Evans School. In collaborations across the Cascadia Coastlines and Peoples Hazards Research Hub, the Center for Climate and Energy Decision-Making, the University of Bergen, and the University of Washington, I study how people perceive and make decisions under uncertainty about climate change, and how communications can influence them. Just as communication is the lifeblood of science, perceptions and mental models of climate change are the heart and lungs of climate science communication. They drive circulation and empower changes in behaviors and action. Mental models of climate change can be simple or complex. Some people equate air pollution and climate change. Others bundle many environmental beliefs together to think about climate change. These strategies can leave people at a loss for what to do, or thinking that a general environmental strategy like recycling is the best they can do, when taking political action or switching to renewable energy sources might be more effective. Learning more about climate change perceptions, communication, and decision-making can inform change for good.
Hello from Antarctica. My name is TJ Fudge. I'm a research assistant professor in Earth and Space Sciences. I'm here at McMurdo Station, the main U.S. base in Antarctica, on my way to South Pole and out to a spot called Hercules Dome. We're going to be drilling an ice core at Hercules Dome, where the goal is to understand if the West Antarctic ice sheet collapsed in a past warm period and potentially raised sea level 10 feet. This issue is dear to me because my parents live within 10 feet of sea level. I'm also here representing the Coldex project, which is searching for the oldest ice in Antarctica back millions of years when the climate was warmer. The travel may be to remote places to obtain these ice cores, but the implications for them affect the entire globe.
I'm Juliette McMains, professor in the Department of Dance. I recently collaborated with 6 undergraduate dancers and composer Paul Matthew Moore to create a dance film installation that pays homage to the wisdom of trees. Filmed amidst the majestic conifers and exposed beams of the Winkenwerder Forest Laboratory, the work imagines a means of human interconnectivity modeled on underground communication networks of trees. The film urges viewers to recognize that urban trees, so many of them stripped naked and nailed together, continue serving humanity in the very structure of our buildings, even when we have failed to protect their habitats. All around us, the trees are whispering. I'm eager to connect with forestry scientists and naturalists who are interested in collaborations on environmental dance films that bring science and art together in creative partnerships.
Hi, my name is Chris Meek, and I'm the director of the UW Integrated Design Lab, a research group within the Department of Architecture in the College of Built Environments. Through interconnected research, technical assistance, and outreach, we seek to create broad-based, replicable pathways to achieving a high-quality, low-carbon built environment. We seek synergies between climate-responsive design, natural systems, technology, and evidence-based practices that create healthy, energy-efficient buildings that serve people and the planet. We partner with industry, utilities, government, and funding agencies to work on buildings that improve human health and productivity while reducing resource consumption, policies and practices that transition our existing building stock to low-carbon, high-value assets, buildings that provide resilience in the face of climate change, and tools and methods that advance the practice of building design and elevate the design community. If you're interested in learning more about the Integrated Design Lab, want to explore partnering, or would like to tour our facility located in Seattle's Bullitt Center, please do not hesitate to contact us.
Much of what I do is to try to understand changes in climate over the last hundreds to thousands to even hundreds of thousands of years. An ice core is a continuous section of ice drilled into a glacier or an ice sheet. We're sending this instrument down, which is just a cutting tool, and the thing goes down a meter at a time. You bring it up and now you have these long tubes of ice. Drilling an ice core is kind of like a time machine. You can go back and find out what was the atmosphere like 50,000 years ago. It's snow that has fallen and it then is compressed, trapping the atmosphere. You can count the layers in ice cores like you can count tree rings. And that means that you can actually determine when certain events in climate happened within a few years. A major thing we've learned from ice cores is that CO2 is higher now than it's been for nearly 1 million years.